On April 24th, 1990, the Space Shuttle Discovery blasted off into outer space and took with it something that changed the way we think about the universe. This shuttle was carrying the first ever space-based telescope that was intended to continue the long-time practice by humans of looking into the night sky and trying to make sense of it all.
The first era of people looking into outer space was with only using their eyes to look up at the cosmos.
About 100,000 to 50,000 years ago, as human brains had evolved to the mental capacity and complexity that they have today, people became curious of life all around them. They began using complex languages and being able to think symbolically through art and rituals and storytelling, and began asking what things are and why they happen. Humans of that time began using the sun, the moon, and stars to help with navigation, hunting, and knowing when the seasons were changing. From 50,000 to 30,000 before Christ, there was a cultural explosion. Humans began using sophisticated tools, creating music, traveling and trading goods and services long distances, and developed early mathematics like counting and tally marks. Meanwhile, archaeologists have found the first known star markings on bone carvings and in cave paintings. These images depict lunar cycles or constellations. Also during this time, people began tracking the moon to measure time. From 10,000 to 5,000 before Christ, while humans began farming and taming animals, they established permanent places to live and created calendars based on the sun and the moon, and became systematic in observing the stars. Astronomy developed to help farmers understand the seasons. People started marking the sky with shapes and figures to help them better remember and understand the sky. And early stone circles, such as the one in Egypt, aligned with the longest and shortest days of the year. Those are called the solstices. From 4000 to 2000 before Christ, the Egyptians and Sumerians developed writing and advanced mathematics, including geometry. Meanwhile, in places like Egypt, South America, and England, more advanced structures were erected to be aligned with important sky events, like the shortest and longest days of the year. Stonehenge in England is one such place. During this time, civilizations began recording planet movements and eclipses. From 2000 to 500 BC, Babylonian astronomers created the first astronomy tables that allowed them to predict when eclipses would happen. Ancient Greeks started asking what stars were made of, how far away are they, and how does the universe work? And amazingly enough, one Greek named Eratosthenes, in about 250 years before Christ, calculated the size of Earth, and he was extremely close in his calculations, no more than 2% off, and he did it all without computers or calculators or even a telescope. People began developing a rational explanation of what they were looking at in the night sky. From 500 BC to 500 AD, after the death of Christ, there were great advances made in logic and mathematics. And while people made errors in trying to create models to explain the sky, like believing that everything revolved around the earth, they were getting better at accurately understanding the sun, the moon, and stars. From 500 to 1200, after the death of Christ, advances in astronomy, mathematics, and glassmaking were coming together that would lead to the modern age of astronomy. From 1200 to 1500 AD, navigation became very sophisticated. So did glassmaking. And so now people could make lenses. Knowledge spread rapidly, and scientific debate became possible. And this ended the first era of space observation, which was by looking at outer space with just human eyes. In 1608, the second era of space observation came, with people now using telescopes to look into the night sky. With the first telescopes, people could see that our moon has hills and valleys and many craters, that Jupiter has moons, Saturn has rings, and that there are spots on the sun. Also in the 1600s, the Milky Way galaxy that we belong to, our sun and Earth are in, was found to include billions of stars. Less than 100 years later, telescopes got much better. The original telescopes were made of glass lenses that were heavy and had to be configured in a straight line. By the end of the 1600s, astronomers discovered that they could use lighter mirrors that reflected the light instead of having light go through lenses. So the images from mirrored telescopes were clearer and less distorted, and as a result, the new telescopes could see further. The mirrors also allowed the light to be reflected back, which meant telescopes could be more compact and maneuverable, which is important when trying to aim them at different locations in the night sky. In the 1700s, the planet Uranus was discovered. It is the seventh planet from the Sun, the third biggest planet in our solar system, and it appears to spin sideways. Astronomers of that century began actually mapping our Milky Way galaxy, and astronomy developed into a quantifiable science. Telescopes in the 1800s helped give birth to astrophysics, which meant astronomers were focused on the position, motion, and shape of planets, stars, moons, and other objects found in outer space. Instead of sending the image from a telescope through an eyepiece, where people could look at it, the light was now directed to cameras or to other equipment that could scientifically analyze the light coming from the cosmos. And with photography, detailed images of the cosmos could be recorded, and thus over time, comparisons could be made and changes in the universe could be detected. In the 1900s, telescopes again helped discover that the universe is so much bigger than people had previously thought. They also discovered light rays that humans can't see, like infrared light. And so now we return to where we began in 1990, when we began the third era of space observation, using telescopes that are located in outer space. That first space-based telescope was the Hubble Space Telescope, and it is still working 36 years later. It is able to capture images that are 10 times clearer than the best images taken from Earth. It was taken into outer space in the cargo bay of the Space Shuttle Discovery, a sister space shuttle to Atlantis, which you see here. The Hubble telescope is the size of a city bus, as this backup model shows. Because its images were much clearer, Hubble could see much further back in time and could recalculate just how big the universe is. Now scientists believe the universe is between 13 and 14 billion years old, while our own Earth is only 4.5 billion years old. In addition to teaching us a lot about outer space, Hubble has taken some stunning pictures through the years. And this is one such photograph, and it is so special that I've produced a video to describe this picture all by itself. You won't want to miss it. The link to that video will pop up at the end of this video. The Hubble telescope has shown that galaxies evolve over time, has found evidence of black holes, and has allowed astronomers to observe galaxies that were formed only millions of years after the Big Bang that created our universe. Thousands of discoveries have been made by people around the world who have access to information and images from Hubble, and that has increased the knowledge that we have of outer space. And now even more stunning discoveries are being made because in 2021, NASA launched a new space telescope, the James Webb Space Telescope. Because it is much bigger than Hubble and is 1 million miles away from Earth, where there is no pollution or obstructions, it has produced clearer images and has been able to look back even further into the universe than Hubble and closer to the time when the universe began. It has been able to detect other planets that are similar in composition to Earth, which suggests there could be life elsewhere in the universe. It has also been able to show the creation of newborn stars and has challenged the way that people have thought that galaxies are formed.
For 100,000 years, people have been looking at the sun, the moon, and the stars, trying to make sense of it all. But seeing is not experiencing something firsthand, is it? In the past 70 years, there's been a push for people to not only look into outer space, but to go there. Someday that might mean going to Mars. And that, my friends, is the focus of one of my next videos.